Hi everyone, we are Team 6. I'm going to introduce you our challenge project that is stock market prediction based on classification using hidden Markov models. So basically, we want to solve the problem that is predict the stock price of certain companies if they will rise or fall in the following week based on our historical data. So using the prediction value, we can develop a simplified trading strategy that is buy the stock we think are most likely to rise in the first day and sell all of the stock in the last day. So what we want to do is to predict the rise or fall of the next 5 days based on the previous n days data. So if we look at this graph, what we actually do is to use the data in the orange window, which is the prediction week, to predict what will happen in the blue window, the decision week. So in this way, we successfully transform the time series prediction problem into a classification problem. This problem formulation is based on two intuitive assumptions. The first one is it is easier to predict the rise or fall of next week rather than predict each single day. The second one is the rise or fall of next week has a predictable relationship with previous n days data. The goal of our prediction is to learn a function that map x into y, where we define y is equal to 1 if the percentage change of the price is larger than 1%. If it is lower than -1%, y is equal to -1. Otherwise, we think y is flat, which is 0. For x, we choose two features. The first feature is the price percentage change of each day. The second feature is the trading volume percentage change of each day. In this way, based on all of the historical data for each time segment, we can generate a data sample x1, y1, x2, y2 until xn, yn. Through random split, we can generate training set and testing set. Through all of these assumptions, we develop our classification method based on hidden Markov model. We build a hidden Markov model for each company, and inside each company, we build three HMM separately for three types of data: rise, fall, and flat. In the training phase, we separate all of the data based on their label and input them into their HMM accordingly. For testing, we run each of the HMM separately on the testing data sample, and they will output their PX. For the three types of model, it will give us P rise, P fall, and P flat accordingly. Based on these probabilities, we can do our next step, the decision making. For decision making, what we really care is the probability difference. The difference between P rise and P fall, and also the difference between P rise and P flat. So based on this, we define our score of each data sample. If the score is higher than a threshold, we will choose to buy this company. Otherwise, we are not going to buy this company. And also for final decision making, we will sort the score of each company based on their previous n days data, and we will only buy the top M companies with the highest score. We first evaluate our model on our testing set. For classification accuracy, we compare our method with a baseline, which is randomly output the data label. It can only give us 1/3 of the accuracy, and our method can give us around 40% of accuracy. For decision making through scoring and thresholding, our method can give us around $40 average profit per week using $1,000 investment, and the baseline can give us only $4 profit. We also evaluate the real-world outcomes. We select three highest score companies. They are MU, Microsoft, and CHTR. And we compare the profit rate of last week of these three companies with the NASDAQ 100 index, which is our baseline. And we found that except for Microsoft, it is slightly slower than NASDAQ index. The other two companies has a higher profit rate than the index. For the trading strategy, we equally split the money into the three companies, and the outcome profit is -$21. However, the NASDAQ index gives us -$35. Finally, we draw the conclusion. We lost money, but the performance of our model is still better than the market index, which means our model is still meaningful. There are many other things we can do to improve the performance. The first one is maybe we can use more advanced feature extraction method to get higher dimensional features. And also we can consider the correlation between different companies and the whole market chain.